Joining us from Major League Baseball is Shanna Shi, an analyst with MLB, who's going to talk to us about StatCast and Baseball Savant and everything that data can teach us. So, Shanna, if you're ready.
Yeah. Hi, everyone.
Hi, welcome back.
Thanks. All right. So let me share my screen first of all, and we'll get this started. This is oh, sorry. Did the thing where Zoom has too many buttons and now I can't find the slideshow button. So this is another version of a presentation I've given a couple of years ago. If you've seen this before, hopefully there's enough new material that it won't bore you. So a little background about myself. I kind of took a weird route into baseball. I mostly put this here just to show that it does not matter that much about where you come from as long as you have the skills you need to be in this industry. So my undergrad was in psychology, which I have used absolutely none of in my day-to-day. I also do not really use the Russian minor in my day-to-day either. I then worked in a chemistry lab for a couple years. I also do not use any of that in my day-to-day either. And then I went to graduate school at Emory University for epidemiology, where I actually do use a fair amount of that in my day-to-day. That is where I sort of like got like the data science that I don't know why I said sort of. That is where I got basically the data science skills that I decided I would just start applying to baseball instead of infectious disease. And so I went from there to an internship with the Toronto Blue Jays, and then I was a diversity fellow there. And then I started here at Major League Baseball in 2021, where I've been ever since. So yeah, just weird route, but I'm here in the end, and that's what matters. So I'm here to talk to you today about baseball data, but also the 3 Ws of baseball data. So that is, what is baseball data exactly? Where do I get this baseball data, and what can you do with it? I should have mentioned that at the beginning, but I will not be actively monitoring the chat while I'm sharing my screen. Please feel free to put questions in there and I'll get to them at the end of the presentation. I do have turn time built in, so feel free to put your questions in, but I won't be able to answer them while presenting. So broadly speaking, baseball data is anything that happens on a baseball field. So this includes what we here at baseball data platforms with MLB call core data. So that's stuff like, what day was the game played on? Who was pitching the 8th? At what point did someone go strike out? What exactly was the sequence for that double play that happened in the 7th? So this is essentially what you would get from a box score or being able to keep track on a scorecard. You should be able to reconstruct a game completely from a scorecard. Maybe not my scorecards, but ideally that's what you should be able to do. But I think of more interest to a lot of us here right now, especially in this like modern StatCast era, is StatCast data. So this helps us quantify any movement that happens on the field. So this is stuff like exit velocity, spin rate, sprint speed, catch probabilities. And for a few years, we kind of had this like gaping hole right at home plate. You know, the pitcher would throw the ball. We know exactly how fast the ball was going. You know exactly how it was rotating. And then the batter would swing at the ball. And there was just this black hole when the batter was swinging at it. And then all of a sudden the black hole disappears because we know exactly how hard the ball was hit. We know exactly how far it's going. We know exactly what angle it's going. But for years, we just had this sort of like black box of a batter's swing and everything because we just didn't have the technology to really quantify that until now. So this gets a little more into Hawkeye, but so in 2020, we switched from TrackMan to Hawkeye as our main tracking provider. This is an entirely optical system as opposed to TrackMan, which was radar-based. So right now, every single major league stadium and also Salt River Fields here in Arizona, they have 12 Hawkeye cameras. We have 5 pitch-to-plate cameras and then 7 more cameras for fielder tracking. So the high frame rate cameras that we installed in all stadiums at the beginning of 2023 are what allow us to do high frame rate capture that gives us biomechanical data for both the for both the batter and the pitcher, but also more importantly for the purposes of this presentation, that's what's finally giving us bat data. So if you go around, like one of my favorite games to play when I go into a stadium is to like just walk around and look at the Hawkeye cameras. This is not actually a very fun game to play, but baseball data is kind of all I think about now. So to me, it's very fun. But yeah, they look like this. You'll see them everywhere in the stadium. Pretty easy to see. So let's see if this will play. So as you can see, we go frame by frame. This is how we track the pitch. can see we're tracking both the ball and all of the joints of the pitcher, as well as home plate. That's how we kind of get reference for where the pitcher is in reference to the rest of the stadium. Let's see if this will play. Hopefully it'll play. And so this is a brief demonstration of how we're getting spin now that we're not using radar. So you can see that frame by frame, Hawkeye uses an algorithm which tries to detect the seams on the baseball. And then because we know the frame rate of those cameras, we can see how much the ball is moving and what direction it's moving between each frame. And then we can derive a spin rate from that. So it's pretty cool how fast we can do this. So moving on to the other part of this, that's going to be R/R Studio. So R is a open source statistical programming language. It's not quite like a computer programming language, like something like C++ might be, but one of the biggest benefits of R is the massive number of user-coded packages that are just available on the internet for basically anyone to use and download for free. So these can be for some really niche things, like whether it's like making phylogenetic trees for like DNA data, or there's also like a bunch of baseball specific ones, which are really cool. But a lot of them are used to assist in either like visualizing, cleaning, analyzing, so it's making models, or even just acquiring data. So examples that you'll probably come across if you haven't used them already include the tidyverse, which is basically a universal package that a lot of people use just for wrangling data in general. LME4 is a linear modeling package, and then both Llama and the Baseball R packages are ones that people use to acquire data. And then RStudio is just an integrated development environment for R. It just makes programming in R much easier. You could do it in Base R, but well, if you do, full credit to you, but I think it would be very hard. So last question, last W, where do you get baseball data? So Baseball Reference is a major source. So there was either a presentation earlier or there will be a presentation later today on Baseball Reference. I'm sorry, I forgot the schedule. RetroSheet is another one. So the Laman package interfaces with RetroSheet's RetroSheet's downloads to be able to parse that out into data sets you can interact with. And then there are other packages like PyBaseball for Python, Baseball R that can help you acquire data, and then also Baseball.computer, which is based off of online queryable database that is based off of RetroSheet's archives that lets you query play-by-play. So those are a couple different sources. The source that I am going to be talking about for the rest of this presentation is Baseball Savant, which some of you have hopefully heard of, but is a pretty powerful tool if you want to get play-by-play data and also StatCast data. So you might be asking what you can do with it, and we are going to go for a live demo because I figured taking screen caps would not be very fun. All right, so Baseball Savant is not actually run by my team, but we kind of provide the back-end data that goes into it. So you've seen like Tom Tango, like Mike Petriello, they're all on the Savant team, and they help basically put everything together here in terms of articles and also these really cool heat maps, stuff like that. So there's a ton of fun things you can do in terms of just visuals. So I really like looking at, let's see if I can find like the Plinko chart. I really like looking at the Plinko charts for see if we can find like Shohei Ohtani's Plinko chart. Fine, if that doesn't want it. Let's do Logan Gilbert. So you can see what kind of pitches he tends to use in the different counts that he gets into. So I just think this is really fun to watch. Okay. We don't have to watch the whole thing though, sorry. But one thing that's really useful is StatCast search. So for example, I can get like a huge sample of every single pitch that was thrown in 2024, if like just by hitting search right here. It automatically will group this for me here, but if you want to get like the pitch by pitch level result, then you can just click on this floppy disk icon here to download it. It's going to take a while actually because it's kind of a large file, but so I've pre-downloaded it actually. Well, okay, just downloaded now. And so if we take a look at that, it ends up looking like, yes, this file here called Savant data. So we can see it's got a bunch of different columns. This is showing us everything like who was every single fielder on the field. So all of these correspond to a unique identifier for each player in Major League Baseball. Bunch of stuff like what inning it was, where was the hit location, who was batting, what was the play result, stuff like that. And so you can see this is all pitch by pitch, so cutter, sinker, everything like that. Other things we can get are, for example, this is new, but I think this is very exciting. We can get bat tracking data, which you can only get group, but it's still really cool to see like, hey, like, okay, Giancarlo Stanton has an 81.2 mile per hour swing speed. So that means he's all the way over here. But we can see on the other end, we have like Luis Arias, who has a low swing speed, but on the other hand, like he squares up to a lot of things. So just seeing this kind of correlation between bat speed and then how people manage to square up and make contact is really interesting. So you can also download this as a CSV. So just hit this download CSV button and it'll appear. So if we look at this, this will be the bat tracking CSV. So you can see we have all of these players and then we can have, and then the number of swings that we have. So this is only using competitive swing. So if someone like fails at like a really bad bunt, we're not counting that as a swing. And then the number of swings that we have, and then the average bat speed across all of those competitive swings. So in terms of what you can do with like this data now that you've downloaded it, I've tossed together a quick model that can show one thing. So I'm going to hypothesize that higher average swing speed is going to lead to higher exit velocity. This, I think, intuitively makes sense, but there might be outliers where they can swing really fast, but they're not, but like their batted balls aren't, the batted balls aren't actually going that fast. And so this is people who are just bad at making contact. Like they have the strength to swing that fast, but maybe there's something they could improve at there. So here we're just going to set the working directory where I've stored all of this data. So if we go into Finder, you can see here we have all of these files. So there's the Savant CSV, and then here's the bat tracking CSV. And then we are going to load it in. So that's what these functions here do. So I'm just going to load these two CSVs in. And then because if we look at the Savant data, since it loaded everything in and a bunch of balls, a bunch of fouls, but I'm only interested in balls hit into play right now because those are the only things that we really care about the exit velocity for. I guess you can make an argument that we should care about exit velocity for foul balls, but that is outside the scope of this presentation right now. So we're going to filter out everything that wasn't hit into play. So this gives us a sample of about 4,330, I think. Where's SD2? Of our original 25,000 pitches. And then we're going to join in the batting data. So what I'm doing is a left join. So this means that I take every single observation from these 4,330 ones, and then I'm keeping all of those and I'm joining in the bat data. So I'll have multiple rows for each batter because obviously they have multiple balls hit into play. And for each one, I'm just adding one more column that is like how fast that they swung the bat. And then because the only things I'm really interested in for the purpose of this model are the launch speed, the exit velocity, and then their average bat speed, I'm just dropping the rest of those variables. That's what I'm doing here with the select statement. I should have mentioned that at the beginning, but like the library I'm using here to do all my data wrangling is tidyverse. So when I'm just using all of these pipes here to filter things out, that just makes things easier when I'm assembling all of the data tables that I'm using. So if we take a look at this, if we take a look at just like the base relationship between swing speed, so that's here on the x-axis, we have average swing speed of each batter, and then exit velocity, that's here on the y-axis. We can see that there's like a relatively straightforward linear relationship here, but I am kind of interested in here with like all of these. This is everyone, so obviously like maybe just people made like complete whiffs here or just made really bad contact. So we're not sure if there's one based on an individual, but it would be interesting to see if there are any outliers like hovering around here that maybe if you're interested in scouting, if this is a player that you think you could coach them to make better contact, maybe that's something that they're currently undervalued and they could be a better asset if they're that people are overlooking. So I'm going to use this LME4 package that I mentioned earlier to make a linear mixed model. So I think I'm not going to be able to give a very good summary of mixed models, but they basically allow me to, for the purpose that I'm using them for, they allow me to account for within correlated results. So a basic linear model would be appropriate if we were using if we got, for example, 4,330 batted balls, and every single one of those was hit by someone, by one different person. So we had 4,330 batters. But the problem is, since we're, using multiple observations from multiple people, your exit velocity one day is probably going to be correlated to your exit velocity the next day, because it's the same person hitting that, hitting the ball. And so what a linear mixed model lets us do is it lets us account for that within person correlation of basically like the same person is doing this, so it's going to look the same because it's the same person doing it. So if we make a basic linear mixed model here, so we're just saying exit velocity, so that's our launch speed variable, is going to be based off of average bat speed, and then we're going to insert a random intercept here that allows us to account for individual variation between batters. And then we're just going to name our data source here. So this should, I think, yes, it did compile pretty quickly, so that's good. And then we can use the random intercepts here. Oops. To take a look at some of the outliers. So if we sort this, so basically like your dead average hitters are going to kind of be like here in the middle. All of these will all sum up to 0. That's just how models work. It wants to balance all of your intercepts out. So if we look at the extreme, oops, this is not quite like a orthodox way of looking at it, but I think it's fun to look at the intercepts to see what you can get out of things to find outliers. So you can see here we've got like a lot of like the people that you expect. We have Aaron Judge here, we have Shohei Ohtani, and then on the negative side we have people like Pete Crow Armstrong, and then for example like Austin Wells. So if we look at Austin Wells' Savant page, we can see here like his speed, he's 60th percentile for bat speed. So you would expect that his exit velocity would be better, but instead it's 34th%. We can see a squared up percentage is at 24. So that's also another indicator that, hey, like maybe there's something he can work on in terms of either trying to improve it. If you're, for example, like if you're in a front office and you're working with a hitting coach, or, if you're like a major league scout and you're trying to look for other players that might be overlooked or undervalued by the team that you would want to trade for going forward. So I think that's just one example of a way that you can use StatCast data along with more advanced statistical techniques to try and fuel baseball making decisions. All right. So that is the end of my presentation, but I am happy to answer any questions right now. So let's see. Let's see. From my experience, what are some tips that I would have given to my past self when I was trying to land my first baseball internship? I think one thing I would definitely tell both my past self and and anyone looking now is that one thing you really want to think about doing is start building a portfolio that you can start showing to potential employers, or that you can just pull out. So whether this is a blog on Medium, or like a blog on Medium, or like maybe like you start writing with like Fangraphs or like baseball prospectus, just something that you can point out and be like, hey, like this is the research I have already done, these are the things I like to study, these are the techniques that I know how to use, and going forward this is where I would like to these are my strengths. We have like internships, for example, like what I really like to see is I like to see that you can think through an entire like baseball like research question from beginning to end. So that's, what are you looking for? What are the limitations of your study going forward? What are the next steps? Are you that sort of thing? And so just having that portfolio of like research you've done, I think is really useful. The other thing I want to say is that I have a lot of people ask me like, hey, what do you think is a baseball question I should start looking into? And I always say that the most important baseball question to answer is one that you want to answer. I think one limitation of anyone doing research in the public sphere is that you're just not going to have access to the sheer amount of data that at the league or in a front office have access to, and that's okay. I think any question that you find interesting enough to want to answer is going to be much more, you're going to be much more interested in it, and we can sense that when someone is actually interested in in like what they're going after, instead of just like, I don't know, like someone told me I should look into this, so I started it, but I wasn't actually like that interested. Like it really does show. So I think that's the advice I would give. How sensitive are the algorithms used for pitch tracking? That's a good question. I think they're fairly sensitive. By Yeah, so our pitch track, so like for example, like our biomechanical, our high frame rate cameras go at 300 frames per second, which I think is pretty good. That does not unfortunately happen in real time just because of the sheer amount of data that it has to process. So unfortunately, just because of like the load it takes on the processing servers, it can take up to 8 hours for some of the biomechanical data to process. And same with the bat tracking can take about, I think maybe like 15 to 30 minutes for a swing to process. In terms of missing data, that is a really interesting question because I was really interested in missing data when I was still in grad school. Honestly, though, I think at this point, like we just have, there's so much baseball data that in terms of just like day-to-day operation, if it's missing, like we just disregard it completely. I think the question is, if the data is missing at if the data is missing at random, which a lot of the time seems to be the case now for us in baseball, just because like if missing data happens, it's often because of, I don't know, like we had like a software crash or a seagull flew in front of a camera and we lost like spin for that because the seagull was in the way of the baseball. And so like a lot of that is usually fairly random. And I'm not as concerned about data missing at random. When it's not missing at random, then that's when you start to get concerned. But I don't think we encounter a lot of that very often. Or if we do, it's because we have one specific issue at a park. But in that case, like we know that's there, and I'm not worried about that biasing findings because of missing data not at random that we aren't aware of. But that's just my perspective as someone who's used to be very worried about just a bias in data science. My favorite finding, that's a good question. I think one of my favorite things I've been working on recently is I've been working on some stuff regarding like infield shifts. So it turns out like some fielders are not nearly as good at remembering to be on the right side of the bag as they should be. And so it's really funny just seeing how skewed that is. I don't think I can comment on who or when, but it's really funny seeing just how bad some shortstops are. I'm sorry, that's not a very fun answer. So personally, when it comes to compiling the data, I used to pull when I was still doing public research, I would pull from Baseball Reference. I think I was pulling from Baseball Reference. I'd also pull from retro sheets databases a lot, or like the Lamin databases. I think now like we have our own internal databases at Major League Baseball, so that's what I'm pulling from. But I would probably also just like heavily lean on like Statcast data because that's Statcast is like the baseball unlike Baseball Savant's like Statcast data. Baseball Savant is sort of like the public facing repository for all of our Statcast stuff. Is there a commonality between baseball and epidemiology that surprised me? In what ways, besides technical data applications, have you been able to apply your epidemiology knowledge to baseball? I think one thing that one of my professors was really wanted to make clear to us was that what we were doing in epidemiology is just data science under another name. And once you know that, then you can take your data science skills and you can use them anywhere. So I think that's kind of like the common underlier. I think another thing is just there's a lot of talk in a lot of fields about causal inference and so the saying like correlation is not always causation. So if you think about something like ice cream sales and homicide rates, that's kind of the classic one. So, as ice cream sales go up, so do homicide rates. But the thing that's causing them, that like the ice cream sales are obviously not causing the homicide rates. It's the rise in temperature that's causing both ice cream sales to increase and homicide rates to increase because people get really irritated when it's really hot out. So thinking about like the causal link between things is something that we do in epidemiology a lot because it's like what is causing the disease here. If we know what's causing the disease, can we focus on an intervention for that one cause specifically? And so just kind of like using that and like really applying it in like weird micro ways to baseball is kind of like interesting thought sometimes. So one thing I kind of like try and think about like how can we apply, for example, like G composition to pitch sequencing, because I know everyone wants to solve pitch sequencing, but because pitch sequencing is so heavily influenced by like what happened right before it, it's hard to deal with in some senses. So I think that's kind of like a fun way to like use like alternative methods that aren't really talked about much to apply them to baseball research. Do ball clubs generally use R or is Python prevalent? I think it's a fairly even mix. When I was with the Jays, I think like it was about like maybe like 50. It was probably more of a Python shop by the end, by the time I left. And it's the same here. Like there's an even mix between like R and Python. I think both have like their own strengths, both have their own weaknesses. So if you know one but not the other, that I generally do not consider that like a disadvantage anyway when trying to apply for baseball jobs. Let's see, bunt data is limited. Is the data from StatCast picking up that exit velocity and pitch speed at those speeds? So no, actually it's not. So especially because we're all optical now, because bunts can go like they end up getting like hit straight into the ground or whatever. We just don't have capture enough of that hit on on camera to have enough frames to analyze that. It's because when Hawkeye like they get the frames and they go, okay, so if we know we take this many frames per second and the ball goes from here to here and we know the field is the distance between that is like however many feet because we've calibrated it. But if you only have like one frame of where the baseball went, and the next thing you know, it's like 5 feet away in the ground because it hit the ground and then rolled. You don't know how far the ball actually went because you only have like the starting data and none of the end data, for example. So that is one limitation that we have. But I think also it's like it's also I think the corollary to that is like how important do you consider exit velocity on bunts? And we've just decided that the trade-off for that sort of trade-off is something that we're willing to make in exchange for the benefits of what we can get with optical tracking with Hawkeye. I don't think I missed any questions so far. Oh yeah, this is one thing. I guess it's kind of topical because we have spring breakout games happening, and also because we've had it we've also had automated balls and strikes in Major League Spring Training for these past couple weeks. But some of it is like some of the optical tracking is like more or less real time. So for example, when someone has like been challenging the pitch, like they go and they tap their head and then all of a sudden we see the graphic on the screen. You can basically instantly see like the graphic on the screen. And it's like, oh, like actually that ball that the umpire called was actually a strike and it was inside the zone by like this much. So so the important data that feels like ABS challenges, we can get that more or less like within seconds. Seconds is actually a really big overestimate. We can get that like really, really, really quickly, but then it's some of the stuff that's like more like data to crunch. So like swings, biomechanical data, those can take on the scale of hours. I think that's always fun to think about, especially with the automated check swing happening in the spring breakout games starting today. All right. I think there's a few more minutes. So if there are any final questions, I'm happy to take them. If not, I will be both at the morning coffee chat on Saturday if anyone wants to speak there, or I'll be around SABR all weekend if anyone's here in person and would like to chat about whatever. But if not, my email is shanna.shi@mlb.com. We're all really easy to find. And feel free to email me if anyone has any questions or would like to just talk about anything. So thanks, everyone.
Shauna, thank you so much. That was wonderful.